Another chapter in my book actually goes over these concepts of distance, adjacency, and interaction. So in this case, we're going to ask these three questions. And when you think about it, this is what GIS is. We calculate distances between objects. We find out if two objects are adjacent to one another or their relationship there, and then interaction. Do they overlap? Do they overlap a lot? Do they overlap a little? Is something contained? Right. So these are the basic topological kinds of questions we ask with GIS. So one of the things we can do is represent them in the form of matrices, and these are then used in models. We've already kind of looked at distance, adjacency, right, with the ST touches earlier, and interaction when we use ST intersects, ST intersection, ST contains. So those are all there, but I want to show you how these can actually be turned into matrices, which become very, very important for spatial operations. And we're actually going to use this a little bit later in a much more advanced lecture in this class. Now to work with this, I've got a layer called 6 cities, and again, you can find that inside DB Manager. You can grab your 6 cities and drag them in. When I say that too fast, it almost sounds like I'm saying sick cities. I don't mean to do that, so it's just the way I pronounce things. So we've got a couple of different cities here. We've got Rochester, Syracuse, Auburn, Ithaca, Elmira, and Binghamton. Now I'm going to show you how we're going to create these data. I've got this one query here, and let's copy this, and we're going to put this now into our DB Manager. Now the first thing I'm going to have to do is drop my existing 6 cities. So I'm going to say drop table 6 cities, and we'll just run that. That's done. So that is now gone. That table no longer exists. So now I'm going to create a table called 6 cities, and part of that creation I have a GID or graphic ID, which is our primary key. I've got a name, which is a variable character, and I've got a geometry, which is a point in latitude and longitude. Then, and notice I'm using my semicolon, so what we're going to start doing now is adding SQL queries together, and each semicolon knows that this one is done, and we can then bring in another one. So the next query is going to be insert into 6 cities. I need to give it the 2 columns. I want to insert it into name and geom. GID is going to be done automatically because I call that a serial primary key, and PostGIS knows that it's going to increment numbers when it does it. So the first value is going to be Syracuse. That's the name of the city. And then the next thing is the geom. Well, that's a make point. This is the latitude and longitude of the geom. And then I'm setting the SRID to be 4326, so it knows it's a latitude longitude point, and that gets inserted. Then I'm going to insert the next one, Rochester, and then Ithaca, Auburn, and so on. So let's just run all of these. Oh, let me get rid of this select star from cities, of course. So let's execute that. So that's done. Now I can say select star from cities, and what we get, 6 cities. There we go. We'll execute that, and those are the 6 cities that we have. And it's what we see on the map. So the data set's created, and the next thing I want to do is look at distance. So this is an example of creating a 6x6 symmetrical distance matrix. Calculating distances between cities is actually really easy, and I'm going to just do that right here. And we'll copy this in here. So here you can see I'm using 6 cities as 6 cities A and 6 cities as 6 cities B. So I'm giving them aliases again. So I want to get the name of the 2 cities of A and B, right? And it comes from the same table. And because this data is in latitude and longitude, I'm going to use the st_distance_sphere. So it's going to calculate the distance over a sphere. Very quick calculations. And again, this is going to return the value in meters, but what I'm going to do is convert that into miles. So let's run this. I'll hit execute. And there we go. So you can see the distance between Syracuse and Syracuse is 0, but the distance between Syracuse and Rochester is 74 miles. The distance between Syracuse and Ithaca is 45 miles. And we can go down through here and see all the different values that we have. This, though, obviously is just a table. Here again, Rochester to Rochester is 0. This is not a matrix. That becomes a little trickier, but I'm going to show you how to do. So to do this, we're going to have to create a table that has the city names along the top and all the distances. And I'm going to actually copy that to a CSV file. So let's just take a look at what this is doing. Here I'm selecting the city names from the layer, right? The 6 cities. So it's cities, and then I've got this name, then a comma, and then I take an aggregate of all the names. So here, select names from 6 cities, order by name. We'll do that. We can execute it, and that's all the names. I'm aggregating those, so that's another SQL clause. And here we go. We'll do that again. So that gives me a comma-separated value of all of my cities. Now, the next thing I'm doing is I'm going to union that with another table. So here we're going to select this one. I've got to make sure I group that. Oh, I just selected the wrong values. There we go. So this now has Auburn, which is a city. And once again, you can see that Auburn is 0 miles away from Auburn, and and Binghamton is the second city along the top. So these are the meters, and then this is how many meters they are away from Binghamton, which is the second one. So let's run both of these now. If I run this, now you can see I've got this comma-separated column along the top: Auburn, Binghamton, Elmira, Ithaca, Rochester, Syracuse, and then I've also got Auburn, Binghamton, Elmira, Ithaca, Rochester, Syracuse, and you can see the diagonals beginning to form. Now the next thing I'm doing is I'm going to create a new file, and I'm going to actually export that. So this query, I'm going to say copy this whole thing to ctemp.dist.csv. So we'll execute that, and that's done. And then I can come into Excel again and say file, let's open that, temp.dist.csv, open that up, and there we go. So this now becomes, here's our diagonal matrix, and you can see the number of meters that they're apart, and we could again adjust that for miles. We can do the same thing for adjacency, and in this case these are points, so they're not really adjacent, but many times we might say if things are within a certain distance of one another, then we would call them adjacent. So in our case, we're going to look at cities that are 50 miles from one another, and if they're 50 miles from one another, we're going to say that's probably close enough to call them adjacent. So let's come back in here again, and let's select all of these, and we'll come back into our DB Manager, and we'll paste that. Pretty much the same query, except I just made a slight change. Here we're going to multiply by that number to get miles, and then we're introducing a case statement. So we're looking at the distance and case when the distance of a sphere, which returns meters, times this 0.00062, which returns miles, when it's greater than 50, then we're going to call it 1. Actually, we got to change that. When it's less than 50, right, then it's adjacent. Otherwise, it's going to be 0. So same idea as before, and let's actually select the whole thing here, and we'll execute that. So again, we've got now adjacencies. You can see what these look like. So it's going to be called ADJ. So let's execute that. That's done, and we come back into Excel, and I can say file open, and then let's go to c:temp.adj.csv, and there we go. So Auburn and Auburn are adjacent. It is not adjacent to Binghamton. It's a little bit too far from there, and it's adjacent to itself, obviously. And Auburn and Ithaca are adjacent to one another. We can look at Ithaca. It's adjacent to Auburn, and it's also adjacent to Binghamton. And again, look at that map that we have here, and you can see Ithaca, Binghamton, and Elmira are pretty close to one another. So again, Ithaca and Elmira are also adjacent. So the last one now is interaction. Now we're not as interested in are they adjacent, but I want to look at the strength of that relationship. So for example, they're all neighbors in some fashion, but you can see that there's obviously a stronger relationship between Ithaca, Binghamton, and Elmira than there would be between Binghamton and Rochester. And Syracuse and Auburn have a much stronger relationship than Syracuse and Elmira. So if we come back down here to interaction, now we're going to look at not a binary of are they within a certain distance, or even a binary of what is the number that they're different by. In this case, what I want to do, so the important part here is to see 1 over the distance. So here, and I'm just putting a little number here just to offset things just slightly, so we don't have some divide by zero errors. But now it's actually an inverse relationship. So things that are further apart are going to have a much smaller fraction. So again, I've kind of run it already down below in my testing, but I can select all of these just like we did before, execute that. And again, we have our names on here, and we'll be able to then create our distance matrix. And just like the other queries, we're going to just copy that to this temp file. Now, again, one of the other things I want to show you, which is really valuable in SQL, this has all stayed the same, right? All 3 of these queries is the same exact thing. We do the union all. This is all the same except what we're doing for distance. Each time we've just changed this slightly. Before we just did distance. After that we did where the distance, we put a case statement in, but it's mostly stayed about the same. So that's done, and let's come back into here and just say file open, and we'll open something on the computer, ctemp, and interact.csv. And now we have, again, one-to-one with these cities, and we have actual relationships between each of them.